Hey, this is Mr. Janes, and this is a solution video to the angle chasing with Algebra Tier 3 worksheet. Since this is a solution video, please make sure you try all the problems first and only watch as much of this video as you need to understand what mistakes you're making. If you watch this entire video before you try the problems, you'll have a poor understanding of what's going on and you won't have much practice. So again, please try these before watching this video. So let's get started with number 1. Number 1 asks us to find the value of b in terms of a. When it says find the value of b in terms of a, what it's asking us to do is to write an equation that starts with b equals, and then some sort of expression involving the variable a. For example, b equals 90 minus a, or maybe b equals 180 minus a, or it could be just b equals a. And so the easiest way to start this is not to think about the variables, but instead to substitute a real value in for one of the variables. So instead, let's say a is 70 degrees. Just for now, we'll call a 70 degrees. Now, what would b end up being? Well, since a and b are corresponding angles, and I know corresponding angles are congruent, I know that b is going to be 70 degrees. So the important part of this isn't actually using 70 degrees because a isn't 70 degrees. We just pretended it was for this problem. Instead, we know that whatever a is, b will be the same thing. So a equals b, or b equals a. So I can circle the correct answer for this, and that ends number 1. Number 2, find the value of y in terms of x. Again, I'm going to have a solution where it's y equals, and then some expression involving x. It could be just y equals x, or y equals 180 minus x, or anything in between. Just like last time, instead of looking at the variables first, we'll substitute a pretend value in for x. So let's say x is 50 degrees, just for now. Next, I'm going to look at the diagram to see how or what process I would use to get from x to y. Well, this is a triangle, and I know all the interior angles of a triangle add to 180 degrees. So, to find out y is, I would probably take 180 degrees, subtract 50 degrees from that angle there, subtract 90 degrees from that right angle right here, and I find out that y is actually 40 degrees. But just like the last problem, this isn't about the 50 degrees, because that was a number I just made up and put in for that angle. Instead, this is about the variables, so let's fill those in. Instead of 50 degrees, I'll use x. Instead of 40 degrees, I'll write y. The 180 degrees will stay, because no matter whether I'm using variables or real values, all of these angles of a triangle still add up to 180. This 90 stays too, because this is a right angle, whether I'm using the variables or not. So I have 180 minus x minus 90 equals y. But that doesn't seem to match any of my answers here. Maybe I could rearrange this equation into an equivalent equation that does match one of these. Well, there's this 180 and this 90. I can combine like terms and write that as positive 90 minus x equals y. Does that appear anywhere? Well, it does. We have y equals 90 minus x. That ends number 2. Let's take a look at 3. Number 3, find the value of q in terms of w. Now I'm going to use the same technique as I did in number 1 and 2, where I'm going to pretend that w is a value for now. But if you're getting the hang of this and you think you can do it without putting a number in for w, try that. For now, let's say w is, 20 degrees. How would I find q? Let's see. Since I know that this adds 90, these two angles are complementary, I would have to take 90 and subtract 20 from it to find out that this is 70 degrees. And since these are vertical angles here, okay, I know that this q will also be 70 degrees. Now, once again, let's back away from the numbers and substitute variables back in. I know that 20 is w and 70 should be q. The 90 will stay because no matter what, whether I'm using variables or values, these two angles here will add up to 90. They are complementary. So I have 90 minus w equals q. Does that match anything I have down here? It does. Let's see right here. Q equals 90 minus w. If you're feeling pretty good about these problems, you could try doing them without substituting in a random value for w. Instead, think of it this way. If I start with angle w, next I have to think about what would this angle be in terms of w? Well, to get from w to this angle here, I would have to subtract from 90. So this angle will be 90 minus w. Then, since this angle here, 90 minus w, and this angle q are vertical angles, this angle will also be 90 minus w. In other words, q is equal to 90 minus w. And I did that without using a random number filled in for w. Instead, I kind of logically went through the steps from one angle to the other and created an expression along the way. Either way works, and if you're more comfortable filling in a number for w, keep doing that. Next, let's take a look at 4. Number 4, find the value of p in terms of r. I'll try this one both ways. First by putting in a random number for r, and next by doing it without that. So let's see here. Instead of r, I'll call that, I don't know, 70 degrees again sounds good, 70 degrees. What will p end up being? Well, if that's 70 degrees, I know that this angle will also be 70 degrees because these are corresponding angles. In addition, this angle will also be 70 degrees, again because these two angles are corresponding. Notice the parallel lines. Then from 70 to p, well, I know that these two are a linear pair. They are supplementary, or in other words, they'll add to 180 degrees. So I know that I have to do 180 minus 70, and that'll be 110 degrees. Now let's back away from the numbers and substitute in some variables. I know that's 70 was r, and the 110, my final angle here, that's p, and this 180 will stay because no matter what, those two angles were supplementary. So p equals 180 minus r, and that matches up with d right here. Again, if you wanted to, you could have tried this without filling in a value for r. Instead, just remember that this r, angle r, will be congruent to this angle r, because they're corresponding. And in fact, it'll be congruent to that angle r, and that angle r, and that angle r, and that angle r, and this angle r, and that angle r, because to get from one to the next, they're all either corresponding, like this one here and this one here, or they're vertical, like this one here and this one here, or maybe they're ulterior, like this one here and that one there. But in any case, it's not congruent to p. So to get from r to p, we'll just look at that. They're supplementary. P must be 180 degrees, take away whatever r is, which is exactly what d gives you right here. So whether you like doing it this way, or you prefer to fill in a variable for r, is fine. Let's take a look at 5. 5 asks us to find the value of z in terms of w. Just like before, we'll start by putting in a value for w. Let's say for now, the w is 140 degrees. How would I find what z is? Well, I'd probably start off by saying that this angle here is a linear pair, it's supplementary, or in other words, 140 in this angle will sum to 180 degrees. So I would take 180 degrees and subtract 140 to find that angle there is 40 degrees. 40 degrees. Next, what would I do? Well, I'd probably notice the fact that I've got a triangle here, and all the angles of a triangle sum to 180 degrees. So I know that I would take 180, subtract off this 40-degree angle here that I found from before, subtract off that 90-degree angle, and I'd find that this missing angle here is 50 degrees. 50 degrees. And lastly, I notice that these two angles here are congruent. So I had a 50-degree angle to start, and z would end up being a 50-degree angle in the end as well. Again, because they're vertical. But remember, this problem isn't all about numerical answers. It's all about using algebra to find the value of z in terms of w. So let's go back to this math that I just did and substitute back in the variables z and w where they belong. Now remember, back in the beginning of this problem, I started by taking 180 degrees and subtracting 140 from it. I did that because 140 was the number I put in for W. So instead, I'll just write 180 minus W. Now, last time I subtracted those and got 40, but this time I can subtract 180 and W. They're not like terms, so I'll just have to leave it as 180 minus W. So this angle is 180 minus W. Once I found that out, I used the fact that this triangle, the angles of this triangle sum to 180 degrees to find this angle here. Well, they still sum to 180, so that number stays. But then the number 40, I don't have anymore. I have this 180 minus W. So I'll have to write 180 minus the quantity 180 minus W to represent this angle right here. Minus 90 degrees for the right angle, that didn't change. And what do I get here? Well, this is strange now. I have to distribute this negative into the 180 minus W to get 180 minus 180 plus W, because remember, negative times negative is a positive, minus 90. And I can simplify that even a little further by combining like terms. 180 minus 180 minus 90 leaves me with W minus 90. So that means that this angle here is W minus 90. And then at the end I learned that these two angles were vertical, so Z will also be W minus 90. So that leaves me with W minus 90 is my answer right here. Now this one's a little more challenging, so let's run through this without doing the whole substituting a missing number thing in. Let's say you want to try this problem without substituting a random number in for W. We can do that. Starting with this angle W, we look at this next angle here and realize that these two angles are supplementary. They add to 180 degrees, which means that this angle will have the expression 180 minus whatever W was. Next, notice that these two angles here are vertical angles. So if this angle is Z, this angle will also be Z. Finally, we realize that there's a triangle here, and all the interior angles of a triangle add to 180 degrees. So I could write 180 minus W, that's this angle here, plus this 90-degree angle here, plus this angle Z here, should equal 180 degrees. Well, that doesn't look like any of our choices down here. All our choices say Z equals. So you'll have to know how to solve this equation for Z to get it to look like one of these. But let's do that now. I'll combine some like terms on the left-hand side. 180 and 90 make 270 minus W plus Z equals 180. Let's see, I'm going to subtract 270 from both sides. Okay, and get negative W plus Z equals negative 90. And then I need to get Z by itself, so I will add a W to both sides, isolate that Z. So Z equals W minus 90. Remember, I can't add negative 90 and W together. They're not like terms. And hey, there it is. Z equals W minus 90. Same option as before. Let's take a look at 6. In 6, we're asked to find the value of M in terms of V. Let's start by picking a value for V. This time I'll say V looks pretty skinny. Let's say it's 20 degrees. Now, we know that this triangle here is going to sum to 180. So I would take 180, subtract 90, subtract 20, I'd be left with a 70-degree angle. With these vertical angles here, so this will also be 70 degrees. And then we've got this other triangle here. We know the angles sum to 180, so subtract off that 90-degree angle right here. I'll subtract off that 70-degree angle right there. I'll be left with, 20 degrees. So it seems that M is 20 degrees, but that's also what I started with. So it's kind of looking like M and V should be the same thing. Let's do this the other way without using numbers, just to confirm that M is equal to V. So this angle would be 180 degrees, subtract 90 degrees, subtract V. That simplifies to 90 minus V. The vertical angle is also 90 minus V. So m would be 180 minus 90 minus 90 minus v. And if you simplify that, you get all the way down to just v. So